Welcome back to the math show. You're gonna leave with more than you already did know. Welcome back to the math show.
Dad, wake up. This is math.
There's no school.
No,
Coronavirus.
get up.
There's coronavirus. There's no school.
No, your math show. Get up.
The math show!
Hello there! Welcome back to the Math Show. Today we'll be covering triangles. We'll be covering areas and finding missing links of them using Algebra.
For a parallelogram, we had one formula. Fit every type of parallelogram. Squares, rectangles, and rhombuses. And it was base times height. Take the base, multiply it how tall the parallelogram is, and you're done. Doesn't matter what kind of parallelogram it was. And today, it's going to be the same for a triangle. A triangle is half of a parallelogram, so we're going to take that parallelogram formula, base times height, and that'll find two of the triangles that you have, and it'll cut it in half. And that's what we want. We want half of a parallelogram. We're going to find the area of a parallelogram and then cut it in half because a triangle is half of a parallelogram. And that's the biggest part of today's lesson. A triangle is 1/2 of a parallelogram. Triangles, 3 angles, right? 1, 2, 3. Sometimes one of those angles is 90 degrees. The altitude or height is perpendicular to the base. You get that 90 degree. It's called a right angle. And these triangles, it's really easy to find the height. All you gotta do is look for this number right here. And this could be the base. Did you also know that we could take a triangle and we could rotate it? This could be the base of the triangle. I could rotate it like this. This could be the base of the triangle. Or in my mind, I could rotate it like this. And this could also be the base, which would change the height. But the two numbers we're multiplying are the same. All right, here is our first triangle. And it is half of this whole thing here. And that's what we're going to do. We're going to find out the area of two triangles, base times height. It'll give us this whole thing here. And then we're going to divide it by 2, which will cut it in half to give us what we want. So let's start off with the formula. Area of a parallelogram is base times height. And then we're only going to want half of that. There's the formula. Area equals base times height divided by 2. So we don't know the area. Let's write an A. We do know the base. The base is the number on the bottom, 8. The height is 11. And that's going to be 88, but we still have to divide that by 2. So if I did 8 by 11, that would be 88. And that would be that right there. This whole parallelogram. So we're going to divide it by 2 to get this. Alright. 88 divided by 2 is 44. And that's squared inches. Not so bad. Just one more step than finding the area of a parallelogram. Here it is. This is not a right triangle. What kind of triangle is this? Do you know? Look at these angles here. You can classify it in 2 different ways. The sides are 15, 16, and 17. All different sides. So I could look at the sides and call this triangle a scalene triangle. None of the sides are the same. I can also look at the angles here. And I could call this, they're all acute, so I could call this an acute triangle. So this is an acute scalene triangle. Alright, so let's see what we got here. Area equals base times height divided by 2. So, if I got the triangle like this, I could have it like this, or like this, doesn't matter. I could call the base any one of those sides, but I'm going to call the base 16 here. So what would the height be? Is it 15? Is it 17? Or is it a different number than those two? Well, here's a very common mistake for 6th grade. A lot of 6th graders will pick this is the height or this is the height, but neither of those are the height. I need a perpendicular line for the height. So it's going to be this line right here. From the vertex straight down to the base, and it's got to be a 90 degree perpendicular. It's gotta be a 90-degree angle, or the lines have to be perpendicular. So that line right there would be the height. So let's measure it and see what we get. 14 centimeters. So that's the height. Right there. That's what we want to use. 14 centimeters. So back in our formula here, we have area equals base is 16. The height is 14. We still need to divide that by 2. So 16 times 14 is 224, and I still have to divide it by 2, and that equals 112 squared centimeters. Man, just looked outside. It's beautiful. Let's go do a problem outside. Yes, it is. Another beautiful day in sunny California. Man, I hope we can find another triangle around here. And that's a little bit different than the ones we already did. And bingo! Check it out. Ooh, that's a sharp one. It's called an obtuse angle. Look at it, it's got one angle that's larger than 90. It's called an obtuse angle. And it looks like the sides, all different measures. So it's also a scalene triangle. It's an obtuse scalene. How the heck are we gonna find the area of this bad boy? It's got one mark here too, that means feet. That's not really 10 feet, that'd be a lot longer. So this is not drawn to scale, as they say. All right, well, when in doubt, if you know the formula, start with that. So I know the formula is the area of a parallelogram. We only want half. Okay, what do we know? Do we know what the base is? Ding, 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 ding. Yeah, it's 4. 4 is on the bottom. We're gonna use that as the base. So that's gonna be a 4. And then we know what a 2 is. What's the height? How tall is this thing? If that's the base, is that the height? Is that the height? What do you think? Is one of those two numbers the actual height of the triangle? Nope. So this is another level 2. We got to find the height of this thing. So we have to draw a perpendicular line. It's not part of the shape. Just extending the base. And what we need to do is draw a line straight down. We're using dashes because we want to make this part of the triangle. And that's 90 degrees, yeah. So this number here is going to be the height. Okay, I already measured that actually, and this is 10 feet. So that's what we're gonna use. So it wasn't 10.6, it wasn't 12 feet, it was 10. So I'm gonna pop the 10 in for the height over here. That's gonna be a 10. So it's gonna be 4 times 10 divided by 2. You probably know what that is. 4 times 10 is 40, and we only want half of that. Yeah, that's 20. 20 squared feet. Once again, we had the triangle. I knew what the base was, but these two were not perpendicular. So we created a new perpendicular line, found the measure of that, and that's the actual height. That's how tall, or the altitude of the triangle, right there.
All right, on to part 2. Now we get to use some algebra. Algebra to the rescue.
Here is a triangle, and I'm telling you that it's a right triangle. And I'm also going to give you this measure here of 6. We don't know what it is, so we'll just call them units. If you don't know what the 6 is, in math land we just call them units. And I'm going to give you a variable. We're trying to find what this side is. I don't know what that is. And we're trying to find it. So we're trying to find x, or find the measurement of this side, which is represented by x. So they got to give me the area of the whole thing, and then I can find it. And which they do. So here's the area. Area equals 18 units squared. So how can I find that missing length? Well, let's just start with the formula and see what we got. Let's plug in some stuff and see what it looks like. All right, so the formula is, once again, the parallelogram formula, base times height, and And we're going to divide it by 2 because we only want half. All right, do we know what the area is? Yes, we do. Let's put 18 in for that. Do we know what the base is? Yeah, well, that could be the base, or this could be the base. I could turn this thing around, and I could call 6 the base, or I could call x the base. It doesn't matter, because it's going to be the same two things multiplied together, same two terms multiplied together. So I'm going to call this the base, and I'll call x the height, and that is perpendicular. So 6 is the base, and the height is what we don't know, x. And divide that by 2. Let's use some algebra steps now. Once again, we're trying to isolate the x there. But before I do that, check this out. That's 6x divided by 2. And 6 divided by 2 is 3. So I can simplify that side to 3x. Because 6 divided by 2 is 3. And on this side, it's just an 18. So I have 18 equals 3x. And in algebra, we want to isolate the x. 3 times x. The inverse operation of multiplication is division. So let's divide both sides by 3 and see what we get. 3 divided by 3 is 1. 1 times x is x. And on this side, 18 divided by 3 is 6. And we got it. And if that's a 6, that means this is a 6. Ooh, these two sides are the same. That's an isosceles triangle. That's when two sides are the same. This one's different. Isosceles. I always remember isosceles because I have 2 eyes. Eyes, isosceles, 2 eyes, two sides. Alright, check this one out. This is like the one we did outside. Here they're going to give you a 6. Here they're going to give you a 10. So the base is 6, this side's a 10. And then the height, remember the height has to be perpendicular? So they're going to give us this stuff, which just is showing the height, and that's what we're trying to find, x. So we don't know that. What's the area? The area of this triangle is 12. They're going to give us that. Alright, we're trying to find the height. So let's use the formula, plug in what we know, and go from there. Area equals base times height divided by 2. Alright, what do we got? Do we know the area? Yep, 12. Plug it in. Do we know the base? Yep, that's 6. Do we know the height? Nope. I'll use x. Alright, and then I gotta divide by 2. Alright, on the left side it's just 12. On the right side is 6 divided by 2. That's 3. And I gotta multiply that times x. Alright, cool. Now we're down to a one-step equation that you guys learned in our algebra unit. So if you want to get the x alone, and that's x times 3. So let's divide both sides by 3. Gotta maintain equality.
Gotta maintain equality. Gotta maintain equality. You got it.
3 divided by 3 is 1. 1 times x is x. Isolated the variable. Nice. On the left side, I got 12 divided by 3, and that's 4. And we don't know what these things are, inches or centimeters or whatever, so this will just be 4 units. This little guy here is 4. Well, that's it. The season has ended. The math show comes to a close. Thank you, everybody, for watching. Thank you, Berkeley Unified School District teachers, for your input and helping get this show out there so students can learn a little bit more and have a little bit more fun while doing it. I had so much fun doing the show, and it wouldn't have been as good without all of your ideas and all of your comments and suggestions. Thank you so much. Thank you, Debbie Dean at Willard, for supporting this project. Jane Itchke for the computer. Man, my computer broke right when I was going to start the show. And the biggest thank you goes to you students. Thank you so much for watching the show. Have a great summer. Please rest up, and we might see you in the fall. See you later, see you later, see you later. Can't say see you on the next math show anymore, no!